April 9, 1941. USS North Carolina was commissioned into the United States Navy. She didn't look like previous American battleships. She was longer, sleeker, more elegant. Her lines suggested speed. Her profile was modern, almost futuristic compared to the squat, heavily armored dreadnoughts that had defined battleship design for decades. North Carolina represented something new, a synthesis that naval architects had been chasing for 30 years but never quite achieved. She was the first true fast battleship, a design that combined the firepower and protection of a capital ship with the speed to operate with aircraft carriers. This wasn't incremental improvement. This was revolutionary. North Carolina and her sister Washington solved a problem that had plagued naval designers since World War I. How to build a ship that could both slug it out with enemy battleships and keep pace with fast carrier task forces. The engineering brilliance that made her possible changed naval warfare and set the template for every battleship that followed. The problem was fundamental. Battleships needed three things: firepower, protection, and speed, but you couldn't maximize all three simultaneously. Physics and engineering constraints meant choices. More armor meant more weight, which meant slower speed. Bigger guns meant more weight. Higher speed required more powerful engines, which took up space and weight that couldn't be used for armor or guns. Naval architects called this the eternal triangle: firepower, protection, speed. Pick two. You couldn't have all three. Pre-World War I, dreadnoughts chose firepower and protection, accepting slower speeds, around 21 knots. Battlecruisers chose firepower and speed, sacrificing armor, a choice that proved fatal at Jutland when several British battlecruisers exploded from magazine hits. The problem seemed unsolvable. The Washington Naval Treaty of 1922 added new constraints. Battleship displacement was limited to 35,000 tons. Main gun caliber couldn't exceed 16 inches. These restrictions were supposed to prevent another arms race. They also forced innovation. If you couldn't build bigger, you had to build smarter. American, British, and Japanese naval architects all wrestled with the same question: how do you fit maximum capability into 35,000 tons? The answers varied, but everyone was constrained by the same physics and the same treaty limits. By the mid-1930s, the treaty system was collapsing. Japan withdrew from the treaties. Germany was rebuilding its navy in violation of Versailles. War was coming. The US Navy needed new battleships, but hadn't built any since 1923. The last class, the Colorado class, including Maryland and West Virginia, were already dated by 1930 standards. They were slow, heavily armored, powerful, but built for a World War I paradigm of battle lines slugging it out at close range. The Navy needed something different. Carriers were clearly the future. Battleships had to be able to operate with carriers. That meant speed, at least 27 knots, preferably 30. But the Navy also needed these ships to fight other battleships if necessary. That meant big guns and heavy armor. The eternal triangle remained unsolved. The design that became North Carolina was the result of years of studies and compromises. The naval architects at the Bureau of Construction and Repair ran dozens of design iterations. Every choice had consequences. Longer hull for speed that increased displacement and reduced armor weight budget. More powerful engines that took internal volume. Thicker armor that reduced speed or required reducing armament. The designers were trying to optimize multiple competing requirements simultaneously. The breakthrough came from incremental improvements in multiple areas rather than one revolutionary innovation. Hull design was critical. North Carolina was 729 feet long with a beam of 108 feet, a length-to-beam ratio that optimized for speed while maintaining stability. The whole form was carefully shaped to reduce drag. Extensive testing in model basins refined the lines. Every curve mattered. Bad hull design would require more power to reach the same speed, which meant bigger engines, which meant more weight. Good hull design meant efficiency, less power needed for the same speed, which saved weight for armor and guns. North Carolina's hull was arguably the most hydrodynamically efficient battleship hull ever designed to that point. The propulsion system was where real innovation happened. North Carolina was powered by 4 sets of General Electric steam turbines producing 121,000 shaft horsepower. That doesn't sound revolutionary until you consider the efficiency. Previous battleships needed similar power for slower speeds. North Carolina's machinery was lighter and more compact than previous designs. The boilers operated at higher pressures and temperatures, 565 psi and 850 degrees, extracting more energy from the same amount of fuel. High-pressure steam technology had been used in commercial vessels, but never in a battleship at this scale. The engineering was cutting-edge and risky. High-pressure systems were complex, prone to maintenance issues, and potentially dangerous if things went wrong. But they worked. North Carolina could make 28 knots sustained speed fast enough to keep pace with carriers. The armament represented careful balance. 9 16-inch guns in 3 triple turrets, the same number as older battleships, but in a more modern mounting. The 16-45 caliber Mark 6 guns were new designs capable of firing 2,700-pound armor-piercing shells over 20 miles. The turrets were electrically powered with sophisticated fire control, but the real innovation was the secondary battery. 20 5-inch 38 caliber dual-purpose guns. Dual-purpose meaning they could engage both surface targets and aircraft. Previous battleships had separate weapons for surface and anti-aircraft use. North Carolina integrated both roles into one weapon system. This saved weight and deck space while providing better defensive firepower. The armor scheme was sophisticated and calculated. The belt armor, the vertical armor protecting the sides, was 12 inches thick, tapering to 6.6 inches at the ends. The deck armor ranged from 1.45 inches to 5.5 inches, depending on location. This doesn't sound as impressive as older battleships with 13-inch or 14-inch belts, but armor isn't just about thickness. It's about protection per ton of weight. North Carolina's armor was arranged using all-or-nothing principal heavy armor over vital areas, minimal armor elsewhere. This concentrated protection where it mattered most. The armor was also face-hardened Class A steel, tougher than earlier armor types. Pound for pound, North Carolina's armor was more effective than older designs, despite being nominally thinner in places. The fire control system was revolutionary. North Carolina had the Mark 38 director system with radar integration. Previous battleships aimed using optical rangefinders looking at the target and calculating distance bearing and speed manually. North Carolina could do that, but she also had radar. The SK Air Search Radar could detect aircraft at 100 miles. The SG Surface Search Radar could detect ships at 20 miles. The Fire Control Radar could track targets and calculate firing solutions automatically. This was transformative. Radar meant you could fight at night or in poor visibility. You could track multiple targets simultaneously. You could fire accurately at ranges where optical aiming was impossible. North Carolina represented the integration of electronics into naval warfare at a scale never before attempted. The anti-aircraft capability was unprecedented for a battleship. Beyond the dual-purpose 5-inch guns, North Carolina carried 16 1.1-inch quad anti-aircraft mounts and 12 50 caliber machine guns. This would be upgraded during the war to 60 40mm Bofors guns and 46 20mm Oerlikon guns. The anti-aircraft battery transformed her into a floating fortress against air attack. Previous battleships were vulnerable to aircraft. North Carolina was designed from the keel up to defend herself and nearby ships. This reflected the lesson every navy was learning: aircraft were the primary threat. Battleships needed to survive air attack to remain relevant. The internal layout showed sophisticated damage control thinking. Compartmentalization was extensive. The ship was divided into hundreds of watertight compartments that could be individually sealed. The propulsion system was divided into multiple fire rooms and engine rooms with redundant systems. You could lose 1 or 2 compartments and the ship would remain operational. The electrical system was distributed. No single hit could knock out all power. Freshwater production ventilation pumping every critical system had backups. This wasn't revolutionary in concept, but the execution was more thorough than previous designs. North Carolina was designed to survive damage and keep fighting. Construction began at the New York Navy Yard in 1937. The keel was laid in October. Construction took over 3 years fast for a battleship of that era. The building process revealed challenges with the new designs. High-pressure steam systems required new construction techniques. The armor scheme was complex to install. The fire control system integration required running miles of electrical cable. The workers were building to tolerances more precise than previous battleships. Every plate had to fit perfectly. Every system had to be tested. North Carolina was launched in June 1940, with fitting out continuing until commissioning in April 1941. Sea trials revealed problems. Vibration was severe at high speeds. The ship shook enough to affect fire control and crew comfort. The cause was complex propeller design, interacting with hull form, creating resonance. The solution required cutting off part of the propellers and adding bulbous bows. These modifications solved the vibration problem, but took months. North Carolina didn't join the fleet until mid-1942, over a year after commissioning. The delay was frustrating, but necessary. A ship that vibrated excessively couldn't fight effectively. When North Carolina finally deployed to the Pacific in 1942, she represented a capability the US Navy desperately needed. The Pearl Harbor attack had sunk or damaged most of the battle line. The carriers were fighting alone with minimal surface escort. North Carolina could escort carriers. She had the speed to keep up and the anti-aircraft firepower to help defend them. She could also fight enemy battleships if necessary. She was exactly what the Navy needed at exactly the time they needed it. Her first major test came at the Battle of the Eastern Solomons in August 1942. North Carolina was escorting the carrier Enterprise. Japanese aircraft attacked in waves. North Carolina's anti-aircraft guns engaged continuously. Her fire control radars tracked incoming aircraft. Her 5-inch guns threw up a wall of anti-aircraft fire. The 40mm and 20mm guns engaged closer threats. Enterprise was hit, but North Carolina's firepower shot down multiple attackers and deterred others. The integration of radar and anti-aircraft weapons worked exactly as designed. North Carolina proved that fast battleships could defend carriers effectively. September 15, 1942, North Carolina was torpedoed by the Japanese submarine I-19. The torpedo hit below the waterline, creating a hole 32 feet by 18 feet. Flooding was immediate and severe. Over 1,000 tons of water entered the ship. 5 men were killed. The damage control teams responded perfectly. Watertight doors sealed. Counter-flooding stabilized. The list pumps controlled the flooding. North Carolina remained operational and steamed under her own power to Tongatapu for temporary repairs, then to Pearl Harbor for permanent repairs. The torpedo that should have sunk her caused 3 months of repairs, but didn't sink her. The damage control design worked. The compartmentalization worked. North Carolina survived because she was designed to survive. The repairs took until February 1943. When she returned to service, her anti-aircraft battery had been further upgraded. She rejoined the fleet for the island-hopping campaign. Tarawa Kwajalein, the Marianas, the Philippines, North Carolina participated in nearly every major Pacific operation from 1943 to 1945. She bombarded islands. She escorted carriers. She provided anti-aircraft defense. She did exactly what she'd been designed to do, operate as part of a fast carrier task force, providing firepower and protection. The carrier admirals loved her. She could keep up. She could fight. Her anti-aircraft battery was formidable. She rarely broke down. The machinery was reliable despite the high-pressure steam systems that skeptics had worried about. North Carolina proved the fast battleship concept worked in practice, not just theory. The Navy built more on the same template: South Dakota class, Iowa class. Each was an evolution of North Carolina's basic design. Faster, better armed, more heavily defended, but fundamentally the same concept: battleships, speed, protection and firepower, synthesized with carrier task force compatibility. The engineering achievement North Carolina represented can't be overstated. The designers solved the eternal triangle not by ignoring one leg, but by optimizing all three simultaneously. She wasn't the fastest battleship, the Iowas were faster. She wasn't the most heavily armed, Yamato had bigger guns. She wasn't the most heavily armored, older battleships had thicker belts. But she was the first to successfully balance all three requirements at a level that made her effective in the carrier-dominated Pacific War. That balance was the achievement. The hydrodynamic efficiency of her hull design would influence warship design for decades. The integration of radar into fire control became standard. The emphasis on anti-aircraft capability shaped every subsequent capital ship. The damage control philosophy, compartmentalization, redundancy, distributed systems became doctrine. North Carolina wasn't just a ship. She was a design revolution that changed how battleships were conceived and built. The comparison to older battleships is stark. Colorado, commissioned in 1923, was an excellent ship for her time, but she could only make 21 knots. She couldn't operate with carriers. Her anti-aircraft armament was inadequate. Her fire control was optical only. Colorado fought well in World War II doing shore bombardment, but she couldn't do what North Carolina did. The 18-year gap between their commissioning dates saw revolutionary changes in naval technology, and North Carolina embodied all of them. The comparison to foreign contemporaries is instructive. Britain's King George V class were roughly contemporary commissioned 1940 to 1942. They were excellent ships, but slower than North Carolina, 28 knots versus 28 plus knots, and less well armed, 10 14-inch guns versus 9 16-inch guns. Japan's Yamato class had bigger guns, 18.1 inches, and heavier armor, but they were slower, 27 knots, and less effective in practice because they were designed for the battleship duel that never happened. Germany's Bismarck was fast, 30 knots, and powerful, but she lacked the anti-aircraft capability and radar integration that made North Carolina effective in the Pacific War. North Carolina wasn't superior in every measure, but her design was optimized for the war that actually happened. The crew of North Carolina developed fierce pride in their ship. She earned 15 battle stars during the war, one of the highest totals of any battleship. She survived torpedo hits, air attacks, and years of hard service. She never failed a mission. Her engineering plant was reliable. Her crew knew they were on a special ship. The nickname Showboat came from a fundraising campaign and a popular song, but it stuck because the crew believed it. North Carolina was a showboat, powerful, visible, effective. Post-war North Carolina was decommissioned in 1947. She sat in the reserve fleet for years. Most battleships from that era were scrapped, but North Carolina survived. In 1961, she was saved by a grassroots campaign in her namesake state. Citizens raised money to bring her to Wilmington as a memorial. She's been there ever since, a museum ship preserved accessible to the public. Walking her decks, you can see the engineering that made her revolutionary. The turrets, the fire control stations, the damage control systems, all still visible. She's not just history, she's engineering history made tangible. The legacy of North Carolina extends beyond her own service. She proved the fast battleship concept worked. That influenced American naval planning for the rest of the war and beyond. The Iowa class were built bigger and faster, but followed North Carolina's template. The Montana class, never built, would have been similar. Even after battleships became obsolete, the design philosophy, balancing multiple requirements, simultaneously integrating new technology, emphasizing survivability, influenced surface combatant design. Modern warships are fundamentally different from North Carolina, but they still deal with the same eternal triangle: firepower, protection, speed. North Carolina showed that synthesis was possible. The engineering teams that designed North Carolina never received the recognition they deserved. Naval architecture is anonymous work. The designers and engineers at the Bureau of Construction and Repair, the civilian contractors, the Navy officers who wrote the requirements, none became famous. But their work changed naval warfare. They solved problems that had stymied designers for decades. They integrated new technologies successfully. They created a design that worked in combat, survived damage, and served effectively throughout the war. That's engineering success at the highest level. USS North Carolina represented a pivot point in battleship evolution. Before her, designers couldn't solve the eternal triangle satisfactorily. After her, the template existed. She wasn't perfect, no ship is, but she was the first to successfully synthesize battleship power with carrier task force speed and modern defensive capability. That synthesis was revolutionary. It changed how navies thought about capital ships. It influenced every battleship design that followed. The fast battleship era, roughly 1941 to 1945, was North Carolina's era. She defined it. She proved it worked. She showed that engineering brilliance could solve problems that seemed unsolvable. April 9th, 1941, USS North Carolina was commissioned. Naval warfare changed that day. The eternal triangle had been solved. The fast battleship had arrived, and North Carolina led the way.